Okay, so here we are on part 4 of the section 4.1 homework, and we're going to get through 27 and 30 in this one. Alright, so on number 27, I should quickly notice that it is a square root of a quadratic, and I know I can't take the square root of negative numbers, so it seems likely in this problem that we might have a limited domain that we can use. And so I'm going to think about the domain to start, and what I really want to know is when is negative x squared plus 2x plus 3 greater than or equal to 0, because whenever it is, that will be my domain. So the first thing I'm going to do is divide by negative 1. And so don't forget, when you divide by a negative 1, you switch the inequality. And so it ends up being this question. So let's factor this. Figure out when it equals 0. I get x, 3, 1, negative 3, and positive 1. So I get it at x equals 3 or x equals negative 1. So the question now is, again, I basically at this point need to do a sign chart of my original function, not the derivative, because then that'll tell me whenever I'm positive, I'm good, and whenever I'm negative, I can't use those values. So I put the numbers I found on a sign chart, but again, this time it's just the regular function. So I plug a number bigger than 3 into my derivative, and I get, let's see here. I guess I can do it. Let's just do it at the original derivative here. So I get 3 squared. I get negative 9. Oh, actually, sorry, I'm plugging a number bigger than 3. So let's plug in a billion. I get a billion squared, and it's negative, and that's going to dominate that term, so I know that we're negative. I plug in a number like 0, and I get a positive, because 0 leaves me with 3. And then I plug in a number like negative 10 billion. And again, negative squared is positive, but now it's negative, and so ultimately it'll be negative. So what this means is my domain of this function is from negative 1, including negative 1, all the way to 3. So this one actually has endpoints. So I should check those. So I'm going to need to find f of negative 1, but I already know what f of negative 1 is. F of negative 1 is 0. That's why I even identified it from the first part. And then I also need to find f of 3, but again, I already know f of 3 is going to be 0, because again, that's what brought it to my attention earlier on. Okay, so now I've got my endpoints. Now the question is critical values. So I take the derivative, and I get 1/2 3 plus 2x minus x squared to the negative 1/2 times, let's do it in this order, negative 2x plus 2. Alright, let's clean this up. And I end up getting, let's see here, in the denominator, I've got the square root. I'm going to put it in the right order of negative x squared plus 2x plus 3. I have a half of negative 2x plus 2, but notice the 2 can cancel out both of those 2's, leaving me with negative x plus 1. So now the question is, when is the derivative equal to 0? And a little quick math can show us that that's going to happen at x equals 1. Set the top equal to 0, move the 1 over, divide by negative, and the derivative is undefined at all values where the square root is negative, which I don't need to worry about because I can't use those anyway. They weren't part of the original function. So all of these values above 3 and below -1 are not going to have a derivative, not because there's a corner or a cusp or anything interesting for this discussion, but just because there's no values out there to begin with. However, notice that I can't divide by 0 either, and so then that brings to my attention the values that would make inside the square root equal to 0, and we already know what that is. That's going to be x equals -1 and 3. So notice those are critical values, which means I need to find out what's happening there, but I already identified those as endpoints. So the good news is if I had not done my domain, I still kind of would have come up with those same values. So it wasn't wasted math by any means, because I was going to have to do it one time or the other. Okay, so what do we know? Let's kind of map out a graph of this thing. I know that my endpoints, -1 is 0 and 3 is 0. I know that my slopes are negative. I'm sorry, these are not my slopes. I haven't looked at slopes yet. These are my original, that's my original function. Let's look at a sign chart. So let's do a sign chart of my derivative. And I'm going to put all my relevant points. So -1, 1, and 3. Again, there's nothing out here. There's nothing out here. 1 was identified because that's when the slope was 0. 1 and 3 are the border of my domain, and I was going to check around those anyway because of the critical values. So I need to pick a number like 2 and plug it into my derivative and see what I get. I plug in 2, and on top I get a negative number. On the bottom I get, well, I've already plugged in 2 to this function before, right? It's just my original function. And when I plug in 2 to it, I get a positive number. Or I could just do it again if I'm not sure what I just said there. So if you plug in 2, I get -4, plus 4 is 0, plus 3 is 3, a positive. So my sign chart shows a negative value. And then I need to plug in a negative number, like, say, looks like -0.5 should do it. And on top, now I get a positive. And on the bottom, when I plug in -0.5, what I'm going to get is still a positive value. Because again, I already plugged in -0.5 essentially earlier on in the process. So I get a slope that is positive. So what does this tell me? It tells me I leave -1 with a positive slope. By the time I hit a value of 1, my slope is 0, and then I head back down to the value of 0 at 3. And so what I know is I have, in fact, a maximum value of whatever f of 1 is, and I plug in 1 to the original function, and I get 3 plus 2 is 5, minus 1 is 4. I get the square root of 4, I get 2. So I have a maximum of 2 at 1, and I have a minimum of 0 at x equals -1 and 3. So max is 2, minimum 0, and I've got all that answered. All right, let's take a look at the last of this section, number 30. Okay, as a rational function, looks like I need to be on the lookout for things like vertical asymptotes. So again, thinking about a domain question, I want to know, when is this function undefined? And so I know it's undefined only when the denominator is 0, because there's no other problematic parts of this function like square roots or natural logs or anything like that. So let's think about the domain. And what that means is I need to figure out if x squared plus 2x plus 2 ever equals 0. Of quick factoring, or like looking at factoring, I'm looking for numbers that multiply to be 2 and add to be 2, and that is impossible. So factoring isn't going to work. I'm suspecting that this thing never equals 0, which would be good for us, but I better make sure. So I'm going to quickly do the quadratic formula. So we should know that. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So a is 1, b is 2, and c is 2. Negative 2 plus or minus 2 squared is 4 minus 4 times 1 times 2 over 2 times 1. Negative 2 plus or minus the square root of negative 4. In other words, I'm getting an imaginary answer. And so I asked it a question. I said, when are you equal to 0? And it tried to answer, and it came up with an answer of never. So that means it's either always positive or always negative. In this case, any number I plug in here is always going to make the value positive. I plug in a number like negative 10, and I get 100 minus 20 plus 2. It's positive. So it's always positive. Okay, so what I've just learned is that my domain is, in fact, all real numbers. All right, and we'll see what implications that might have as we get closer. Okay, so no endpoints to check. So let's start looking at critical values. And I'm going to take the derivative. And I have to do my favorite quotient rule. So the derivative, hopefully I have enough room. Derivative of the top is 1 times the bottom minus the top times the derivative of the bottom, which would be 2x plus 2 all over the bottom squared. All right, so since I'm going to need to do a little bit of math with this, it makes a lot of sense to clean this up. And that's squared on the bottom. All right, so foiling on top, I get minus, I'm going to put it in parentheses, x times 2x plus 2x plus 2x plus 2 all over the denominator, which I'll just leave off for now. So x squared plus 2x plus 2 minus 2x squared minus 4x, 2x plus 2x, but it's negative, minus 2. All right, so let's cancel out the 2's. Plus 2x and minus 2x. So it looks like I get a derivative of negative x squared minus 2x over all of that stuff squared. So once again, I did this to find out when is the derivative equal to 0, and that's only going to happen when the numerator equals 0. I'm going to factor out a negative x, leaving me with x plus 2. So that's going to happen at x equals 0 or x equals negative 2. So there are two critical values. But then I also need to figure out when the derivative is undefined. And again, the work I did with domain is going to help me with this. So it's going to be undefined whenever the denominator equals 0. And if we look at the denominator, x squared plus 2x plus 2, it's the exact same denominator we had before, except now it's squared. We found that x squared plus 2x plus 2 never equals 0. Right? Didn't work out. So I know that the denominator is never going to equal 0 on my of my derivative. So I'm not going to have any more critical values. All right, so now it's time to look at a sign chart for my derivative. Putting on my critical values, I have -2 and 0. Those are the only places where my slopes are going to change. So again, looking at the derivative, plugging a number bigger than 0, like 1,000,000,000. I go to my derivative over here. The top is going to be 1,000,000,000 squared, and it's negative, minus another 2,000,000,000. So the top is negative. The bottom is squared. It's always positive. So my slopes are negative on the right side of 0. Plug a number like -1, because that's between 0 and -2. Now I got to be a little more careful with my math. The bottom is still positive. The numerator, -1 squared, is +1, but now it's negative. Minus 2 times, and that's going to be +2. So it looks like now we've switched to positive. And then plugging in -10,000,000,000 or so, I square that, it becomes positive, but now it's negative again. So I get negative. Alright, so what does this tell me? Let's see if we can piece together a possible graph of this. I have at 0, I know, actually I could figure out what the value is at 0. Plug in 0 and I get 1/2. So there's 0 1/2. I know that as I leave 0 1/2, my slopes are negative. So that means I start going down. The question is, do I go down dramatically and head to -infinity, or do I head off to some sort of horizontal asymptote? So that's still to be figured out. I also know that as I leave 0 on the other side, my slopes are positive, which means I'm coming up towards it. So what I really need to know is what's happening at -2. So I already found f of 0 was 1/2. Right now, that's looking like my maximum value. F of -2 is going to be -1 over, let's see, 4 minus 4. Is this right? -2 squared is 4, minus 4 plus 2. So I get -1/2. So as I leave here, I'm going to come down to -1/2. And then I know looking at my sign chart, my slope was 0. And then my slopes are negative. So again, the question is, I'm coming down, so do I look like this? Or is it possible that I'm bending off to a horizontal asymptote? So those would be pretty important questions to figure out if this is a maximum or a minimum, or if it's just local max or local minimum. So I am going to ask the question, what is happening to this graph as I go to infinity? And quickly notice that the power on the bottom is greater on this rational function, and that tells me my value is 0. And that would be the same on the other side. And so let's just double check. Yep, power is greater, so I go to 0. So what this means is I leave here and I actually do level off to an asymptote here, and I level off to an asymptote here. So my local values I found at my local minimaximum I found at my critical values do in fact turn out to be the maximum and minimum values. So I know now that 1/2 is my maximum, -1/2 is my minimum, and I know where they both occur. And at 19 minutes, this video is going to take a long time to upload. This ends, I guess, part 4, and we'll probably have a part 5.